Welcome to the DIY Honda Garage channel. DTC P1458 indicates a problem in the fuel tank pressure sensor circuit within the Honda Civic models from 2011 to 2015. The FTP sensor plays a critical role in monitoring the fuel tank pressure within the EVAP, Evaporative Emission Control System, which prevents fuel vapors from escaping into the atmosphere. This component is typically located near the fuel tank, connected to the EVAP canister, and works by sending pressure readings to the Engine Control Module, ECM. A malfunction in this sensor can lead to increased emissions and may trigger the check engine light. Prior to troubleshooting, it's essential to record all available diagnostic data and snapshot information from the vehicle systems. This data will provide a foundation for identifying potential causes and may highlight other DTCs that need to be addressed, such as P0451, P0452, P0453, P1454, or P2422 before revisiting the P1458. Ensuring a thorough understanding of the components involved and procedural adherence will facilitate effective troubleshooting. The fuel tank pressure FTP sensor is designed to measure the pressure inside the fuel tank to ensure proper functioning of the EVAP system. Located close to the fuel tank, this sensor serves a vital role in determining if the fuel system is sealed properly. The sensor's readings are essential for the ECM to control the emission system effectively. If the FTP sensor detects abnormal pressure levels, it may indicate potential leaks or blockages within the system. The readings help maintain fuel vapors inside the tank and ensure they are funneled back into the engine rather than being vented into the atmosphere, thus reducing harmful emissions. If the FTP sensor is malfunctioning, it can cause inaccuracies in the fuel system's operational metrics, leading to a triggering of the DTC P1458. Several factors may lead to the P1458 error code. A faulty FTP sensor itself is a common cause, which may produce altered readings or no readings at all. Wiring issues like short circuits or frayed wires can interrupt the transmission of data to the ECM, causing the DTC to trigger. Another potential cause includes blockages in the vent hoses connected to the FTP sensor, which can affect its ability to measure pressure accurately. Additionally, malfunctions in associated components like the EVAP canister vent shut valve may also contribute to the detection of this error code. Each of these factors must be considered during the troubleshooting process to eliminate false conclusions and ensure accurate diagnosis. When DTC P1458 is triggered, the most common symptom is an illuminated check engine light on the dashboard. This light serves as an early warning sign that there is an issue within the vehicle's emission system that needs urgent attention. Drivers may also notice a decline in fuel efficiency, as the engine may struggle to perform optimally without accurate pressure readings from the FTP sensor. Furthermore, a malfunctioning FTP sensor can lead to increased emissions, which not only harms the environment, but may also result in failing emissions tests. Addressing DTC P1458 is critical in maintaining the vehicle's performance, compliance with emission regulations, and overall driving experience. The first troubleshooting step requires checking the vehicle's fuel level, as this can directly impact the readings from the FTP sensor. Begin by turning the ignition switch to the on position, without starting the engine. Then, using the HDS, Honda Diagnostic System, record the snapshot parameters including the maximum and minimum values of the FTP sensor and the current fuel level. It is crucial to establish whether the current fuel level is lower than the recorded value on the snapshot. If it is, you should proceed to the next step. If not, Drain enough fuel to ensure that the level is lower than what was originally recorded. Note that inspecting the fuel level is essential for accurate readings from the FTP sensor during subsequent diagnostic steps. Once the fuel level is confirmed, the next step involves determining the possible failure area. Again, avoid starting the engine and take a snapshot with the HDS for approximately 3 minutes while the ignition is on. This snapshot will capture operational parameters necessary for diagnosing the FTP sensor. After capturing the data, focus on both the maximum and minimum values of the FTP sensor. The difference between these values is key. It should be about 0.67 kPa or less. If the difference exceeds this threshold, further investigation is warranted into other potential failure areas. This step is vital as it helps pinpoint whether the issue lies solely with the FTP sensor or is indicative of broader EVAP system malfunctions. The third step focuses on a direct performance check of the FTP sensor. Monitor the recorded values to see if the FTP sensor shows variations of about 0.067 kilopascal over a duration of 3 seconds. This precision evaluation is critical, as consistent readings may suggest that the sensor is functioning properly, while significant variations may indicate an intermittent failure. If the sensor operates within the expected parameter range, it suggests the system is currently functioning correctly. Although further checks for loose connections or poor terminals at the FTP sensor, ECM and EVAP canister vent valve should be performed. Thus, this step emphasizes checking not just the sensor, but the overall integrity of the connections in the system. In step 4, further performance checking of the FTP sensor is conducted. Begin by turning the ignition switch to the lock position and remove the FTP sensor from its connector. Reconnect the sensor's 3P connector without reattaching it to the system. Again, turn the ignition switch back to the on position. 2. Ensuring that the engine remains off. With the HDS, monitor the FTP sensor's values to determine if there is a change of 0.067 kilopascal over a period of 3 seconds. If so, this might confirm the need for replacing the sensor, as constant variations could indicate that it is malfunctioning. Coincidentally, if it doesn't show any significant changes, you should still check for poor connections or obstructions within the system that could indirectly affect sensor performance. This step shifts focus towards potential failures outside the FTP sensor itself. Start by removing the fuel fill cap. This is a critical action as it allows the pressure in the fuel system to equalize. Next, recheck the FTP sensor values with the HDS to assess if the readings are approximately 0.67 kilopascal or more, or about negative 0.67 kilopascal or less. If the values fall within this range, reinstall the fuel fill cap and progress to step 8. However, if these readings are not as expected, you will need to proceed to the next troubleshooting steps to further investigate other components that may be causing failures in the EVAP system. In this step, you will check the FTP sensor vent hose, as any blockages could skew its readings. Begin by turning the ignition switch to the lock position. Then, remove the FTP sensor again and ensure the 3P connector is reattached. Switch the ignition back to the on position without starting the engine. Once again, utilize the HDS to monitor whether the measured pressure values hover around the specific thresholds of 0.67 kilopascal or greater, or negative 0.67 kilopascal or less. If yes, you will need to remove any detected blockages in the FTP sensor vent hose and consider replacing the hose itself if necessary. This step is vital to maintain the proper functionality and accuracy of the FTP sensor. Step 7. centers on performing a thorough visual inspection of the FTP sensor itself and its ports. To begin this process, turn the ignition switch to the lock position and disconnect the 3P connector from the sensor. Assess the ports on both the EVAP canister side and vent side for any blockages or physical damage that may hinder sensor performance. If you find any debris or obstructions, remove them to restore proper flow. However, if no damage is identified and issues persist, it may be necessary to replace the FTP sensor to complete the diagnosis. This step ensures that both the sensor and its connectivities are functioning optimally for accurate readings. The final troubleshooting step focuses on the EVAP canister's fresh air intake system. First, turn the ignition switch to lock before disconnecting the fresh air hose from the EVAP canister. Next, connect a vacuum pump or gauge to the vent shut valve and turn the ignition to the on position. Here, it's essential to apply vacuum not exceeding 5.3 kilopascals, as higher pressures may damage the FTP sensor. Monitor whether the valve holds more than 1.3 kilopascals of vacuum. If it does, the fresh air hose is deemed operationally sound, and it may be necessary to replace the EVAP canister vent shut valve if issues persist. Conversely, if vacuum fails to hold, removing any blockages in the fresh air hose is critical, along with potential replacement if damages are evident. After completing all necessary repairs, it is crucial to verify that corrective actions have resolved the issue. Begin by turning the ignition to the lock position and ensure all connections are properly reconnected. Subsequently, utilize the HDS to reset the Engine Control Module, ECM, which clears any existing DTCs and prepares it for fresh data. Execute the ECM idle learn procedure to ensure optimal engine function post-repair. Following this, take another snapshot for approximately 3 minutes without starting the engine to evaluate the FTP sensor parameters once again. If the difference between the maximum and minimum values remains about 0.67 kilopascals or less, it confirms that troubleshooting has been successful. If not, it will necessitate revisiting the diagnostic procedure and addressing any overlooked issues. To prevent future occurrences of DTC P1458, several preventive maintenance measures should be implemented. Regular inspections of the FTP sensor and its wiring can help catch early signs of wear or damage, which are crucial for ensuring reliable operation. Additionally, cleaning the components of the EVAP system can prevent blockages that hinder performance and lead to error codes. Keeping an eye on fuel levels is also important, as fluctuations may skew sensor readings. It's advisable to consult the owner's manual for specific service intervals and to follow a consistent maintenance schedule. These proactive steps can significantly reduce the likelihood of recurrent issues with the FTP sensor and enhance the longevity of the vehicle's emission control system. In conclusion, DTC P1458 indicates a critical issue with the FTP sensor within the Honda Civic models 2011 to 2015. This troubleshooting process highlights the importance of understanding the sensor's function, knowing how to check related parameters, and recognizing the signs that a failure may have occurred. Since various interconnected components can lead to the triggering of this DTC, comprehensive checks are essential. Regular maintenance practices also play a significant role in preventing future complications. Equally, following the outlined troubleshooting steps systematically will not only enable an accurate diagnosis, but also contribute to the overall health of the vehicle's emission control system. A well-maintained system is vital for compliance with emission standards and for avoiding costly repairs in the future. Please like and subscribe to the channel. See you next time.